Hello everyone. Today our topic is how to read multi-line complex or nested JSON file. So first we'll see what is multi-line nested JSON. So if you see, this is the example for multi-line means inside this JSON object that is starting with floor bracket and this floor bracket. And if you see each and every line, so that means each and every key value pair, it is in separate line. See, in case of single line, it will be in single line. So JSON object will be in single line, but here each key value pair, it is in individual line. So this kind of format will call as multi-line JSON. And what about nested JSON? So inside this multi-line, so this is one JSON object starting from floor bracket to here. This is one JSON, and inside that we have two more JSONs. So this is one JSON and this is one JSON. So if you have JSON inside JSON, then we'll call as nested JSON. So since it is multi-line format, we'll call as multi-line nested JSON. So this is initial JSON object, and inside that, this is first nested JSON object. So here key value is address and value is JSON object. And again, this is one key and value is again JSON object. And if you see at the starting and ending, you will see square bracket. So that is JSON array. So this finally multi-line complex JSON file, it will be in this format. So starting and ending square bracket and in between multiple JSON objects. So same thing we can see here. Once you upload JSON file into Databricks, and if you try to open this one, so initially it will show like this. So here starting and ending is square bracket. So that is this one. And inside that it will tell you that 7 items are there. So that means if I expand this one, see here inside that we have 7 JSON objects we have. And again, each JSON object, it has 12 items. So if I expand this one, see here, this is one item, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and it is mentioned 12 items. Up to here 10 and two more sub JSON items we have. So, and again, if you see this sub JSON object, this is key is the address and value is the JSON object. And again, this in JSON object, we have 4 items. If I expand this one, so I have here 4 key value pairs. And at the same time, for second key, that is domain, and value is again JSON object. So this JSON object has again 4 items. If I expand this one, so we'll be having this one. So whatever I shown here, so if you open in Databricks catalog, it will open like this. So initially it will be in collapse mode. If you expand these things, it will open like this. So this is about JSON, multi-line JSON, nested JSON. Okay, so now we'll see what are the different methods are available to read multi-line JSON, nested JSON object. So first what I'm doing, I'm defining one variable that is the path of my JSON file. So this is the path I'm defining here. And in first method, what I'm doing here is spark.read.json, and inside JSON, I'm passing this path. And since this is multi-line JSON, so we need to pass multi-line equal to. So this is method 1. And method 2 is spark.read, and this option, this multi-line equal to true, this option I'm writing separately like dot option multiline true. And this path I'm writing as it is, like dot JSON path. So this is method 2. And method 3 is spark dot read dot format. Format is JSON dot format JSON and option. So this is multiline true and dot load path. So the path I'm passing here. So these are the three different methods available to read multiline nested JSON file. So first we'll see first method. So how to read multi-line nested object. So nested object means, so here I have only one object. So first we'll see how input looks. So JSON, read JSON, multi-line nested, multi-line complex nested JSON, multi-line complex nested JSON, nested JSON. Nested JSON. Okay. So if I see this particular file, so here I have starting and ending is square bracket, and inside that it telling that one item. If I expand this one, so I have inside that one JSON object, and that JSON object I have 12 items. So if I expand again this one, see here first 10 are key value pairs separated in individual lines, and last two are, this is key and this is again JSON, this is sub JSON, and this has again 4 items, and one more key, that is domain. It has JSON object and it has 4 items. If I expand this one, these are the 4 items. So here what I did is, here I took only single JSON object instead of multiple JSON objects. I took single JSON object. If you see here, if you try to expand this one, it will show you the tree. See, it's showing the tree. So next, we'll see how to read this one. So first I define the path, then spark.read dot option. In option, I'm mentioning multi-line equal to true, then dot JSON path. So here what I used second method. So you can use any of the method, but here I tried with method 2. So then I'm trying to display this particular JSON file, and later I'm trying to print the schema. So since we have single JSON object, it printing, see here, one is address is there, and inside that we have two JSON objects, right? If I open this one, so we have two JSON objects here. So one is address, one is domain. So this address JSON object, it showing in separate column. Here address, and this is struct type, and these are all the four values, four key value pairs we have inside. And these are all individual columns. So record number, state, zip, all these 6 individual columns. And we have one more JSON object, that is domain. So it has 4 values. And one more thing, so while reading JSON file, there is no guarantee that it will come in same order. So that means this is one key value pair. So in this key is the column name. That means these are all column names, and address, domain, these are all column names. But here, what is their first? Record number, source, description, input, timestamp. But if you see here, so it will come its own order. So first it coming address, then record number, state, zip code. So it not coming exactly same order. That is one thing in while reading the JSON file with the default method. So default method means infer schema. Infer schema true. So infer schema true means here we are not providing explicit schema. So Spark itself reading the file and detecting the data type, and it giving its own column order. And you can see here the schema of this particular JSON file. So here first we are getting address, right? So address, if you see, address is the struct type, and inside that we have these four columns, and those four columns data types we are getting here. So since here it is infer schema equal to true, so all these data types like address is tracked, and inside address we have location and individual data types. So due to infer schema equal to true, Spark itself identifying all these schema and their relevant data types and record number. These are all individual columns. So they're relevant data types. And if you observe here, record number, long data type is there. But if you see record number, we have one. So due to infer schema equal to true, so Spark is identifying this record number as long, but it should be generally int type. So this we'll see further how to define that one. And zip code, we are getting long type. We'll see how the value is. So this is fine. So since this is big value, so long type, it is fine. So next, domain. So domain it detecting as struct, and if you see here domain, so this is struct, and these are all the four key value pairs. See here this. So they are relevant data types it detecting. But if you see age and experience, so age is 26 is there, experience is 5 is there, but generally it should be integer type, but it detecting as long type. Okay, and input timestamp. So input timestamp. So these two are fine. So these two are long data type. So this is fine for us. Okay. So this how this multi-line nested JSON file reads, and it displays the data type, or you can say schema. So next I have one more JSON, that is multi-line complex nested JSON. So multi-line complex nested JSON. So here what I have, here I have multiple JSON objects. So earlier we saw single JSON object. So here starting and ending it is square bracket, and inside that we have 7 items. If I expand this, see here I have 7 JSON object. And in first JSON object, I have 12 items. If I expand this one, so here these first 10 are individual key value pairs, and address and domain, I have again JSON object. So whatever we saw earlier, that is this one. So that is single JSON object up to here. And here what I have is, I have 5 more, 2, 4, 6 more JSON objects like that. So if I expand this one, see all are will be similar way like this. So JSON object and again JSON object. And if I expand one more, so here also 10 and again address domain. So like this, I have 7 JSON objects. Okay. So this is multi-line nested JSON. So and if I try to read this one, so the code is same, everything is same. So only difference is to previous one and here. Earlier we have only single JSON object. So, but in this file, I have total 7 JSON objects. So remaining all same. If I try to expand this one, so you will see this 4 values inside this JSON object. Okay, so here also same. Okay. So this how it reads the multi-line JSON object. So this schema is also same. Whatever I give an explanation in previous scenario, it is same. Now, what I'm doing, this multi-line JSON, nested JSON, I'm trying to do flatten here. So for that, I'm importing the functions as f, and from this sample data frame, that is this one, MLT nest JSON. So I'm using select statement, and inside select statement, whatever straightforward column is there, that is individual columns are there. So that I written first. And later, whatever we have nested JSON. Suppose if you see address, this is our first nested JSON object. So how to access these columns inside this address? So since it is a struct type, so we can directly access by using dot method like address dot location, address dot country name, address dot pin code, address dot username. Okay, so same thing I written in select statement like call method, address dot pin code, address dot location, address dot country name, address dot username. So this is possible only in case of this address key if it is struct type. Okay. If it is any other type, array type, so we cannot directly access it. So we have to use some other methods. And similar way here, domain is struct type. So we can directly access like domain.age, domain.level, domain.experience, domain.technology. So same thing I written here. So now what will happen if I try to display this one? So you don't see any sub nested JSONs here. So all are flattened now. See here, you don't have any struct type here. And if you see the schema, so earlier we have this, right? So address, this is one nested JSON, domain, this is one nested JSON. But after doing flatten, see here, everything, the structure is, everything is flat. Okay, so next, how to read multiple files from single file. So that is the directory reading. So if you have single line, so this is multi-line, not single line. So we have multi-line complex, multi-line can say complex or nested JSON files. So stored in one folder. So pass the directory path instead of a file name to load them all into a single data frame simultaneously. So this when we'll use is, suppose if we have file with mixed data types. So one is mixed data types, but here we'll see uh, first method. So first method is, suppose I have in this particular path training JSON under JSON, read JSON under JSON, read JSON, multi-line nested scheme, same scheme. Read JSON, multi-line nested, same scheme. So here I have three JSON files. So in this folder, I have only JSON files and I want to read all these three JSON files at a time. So then I can use this method. So like first, I'm defining three variables like path 1, path 2, path 3. In path 1, I'm giving the path of this first JSON file. So here I'm doing copy. Suppose, yeah, so I'm copying this path and each and every path. So first I'm copying and pasting there. Then second one, I'm trying to copy the path and I'm pasting here. So this is first JSON path and this is second JSON path and this is third JSON path. So I defined the paths of each file. Then what I did, I spark.read dot format is JSON format. Next option multi-line is true and dot JSON inside JSON. So earlier case, what we did, we simply mentioned the path. So inside JSON, we mention simply one path variable because earlier case we have single JSON path. So since now I have multiple JSON files, what I'm doing, I'm passing the list. So inside list, I'm passing all these variables, path 1, path 2, path 3. So now what will happen? All the three JSON files, it will read together one by one, it will read. How it will read is if you open this first JSON file, so it has 7 rows. Okay, so if I expand this one, in this record number is 1, it is starting with 1 and ending with 7. And those things, those records you can see here. So 1 to 7. So first it reading first JSON file. So that is 1 to 7. Next, second JSON file is it starting with 8 and it is ending with 14. So 8 to 14. So this is second file. And next, if you see third file, so here first one is 15, starting is 15 and ending is 21. So 15 to 20. So three files it reading one by one. So first it read first JSON file, then second JSON file, then third JSON file. Okay. So this is one method. So total how many we are getting? 7 into 3, 21 rows we are getting here. So that means all the JSON files it reading together. So now this is same. So as we discussed earlier, that is same. There is no change in that. And second method is, so this I can mention as method 1, but it is not suggestible to use in real time, this particular method. Why? Because uh, suppose if I show you here in method 2, in method 2, suppose my folder has multiple formats. So JSON, read JSON, multi-line nested, same schema. So this is one thing, that is same path, and we'll try for other thing also. So here what I'll do little change here. This one I will move to separate cell. So in method 2, what we can do is we mention the path, the root path we can mention. So that is this one. So we can copy this path and we can mention that path here. So next, spark.read option multi-line as true and JSON path 4. And this is same. So now what will happen? It will go to this root folder and whatever the files are there, it will read all the files. Since we have here only JSON files, so we don't have issue here. Like we don't have issue since we mentioned .json, it will read only JSON files. But in case, so here, this also fine. This also method 3. So here what we are doing, we are giving the root path. So here we are giving the root path. And here what I'm mentioning here is in that root path, I'm mentioning to read only star.json. So that means in this particular path, I'm asking to read only JSON format files. So not other files. And when it matters is, suppose this particular case, what I will do, I will try to read one more folder which has mixed files. So for that, I will go here, mixed files. So if you see here in this root path, here I have, this is one log file, and here I have three text files, and I have three JSON files and two CSV files. Suppose in this root path, what I will do, this root path is same, and this is, I will mention as mixed type, and here also mixed type, and here also mixed type. So now what will happen? It will go to this particular path. I given only path here. So I'm not mentioned any format here. So what will happen? Since I mentioned here .json, it will try to read only JSON files from this folder. Since I mentioned only .json, it will try to read only these three JSON files and will get only same result will get. Okay, so but sometimes what happens is, so this one here also what I'll do, if I mention mixed path, I think okay, so here I'm not change the path, I need to provide the path. So that is the reason it not coming correctly. Okay, see now I given the root path here. So in this we have all different formats we have, but what I mentioned here is .json. So what happening, you're trying to read all the format files. So whenever we give .json and option multi-line equal to true, what will happen? Whatever correct JSON files are there, it will read those files correctly, and remaining files, it will move to this corrupted column. So that means if you see this one, these three records are related to JSON file. If you see here, this one, single line JSON, see here, this many columns we have. So serial number, first name, last name, and it has total 11 rows. Okay, so like that, we have three JSON files. So it will read only those, it will read only those JSON files correctly. And whatever we have extra, this is serial number status. Maybe suppose what I will do, I will try to open this one CSV file. It has serial number, status, start date, end date. So since this is CSV format, and since we mentioned here .json, since it is not supporting, so due to this .json method, it considered as bad record. You can say bad record or corrupt record. So what it doing for all the columns, see here, for all the columns, it providing as null because none of the column is matching. So whatever whatever we have these columns, it is not matching. So it's simply throwing under corrupted record. So if you see here, see all the entire CSV file, it thrown under corrupt record. And here also it thrown in corrupt record. And if you come to TXT files, so in README, we have this one, this folder. See three lines we have, and this dash. And if you see here, so this is the one, this that entire thing is reading as correct record. And whatever we have this one, this is two text files. So these two text files, it reading this, these two, yeah, these two text files, it reading and it moving under correct record because format is not matched. So this is one thing. And and what I can add here is dot option mode I can add dot option mode as permission. If I rerun this one, see currently we have only three rows it read, right? So 3 rows, Rakesh, Smith, Tanvi. So Rakesh, it reading only Rakesh, Smith, Tanvi. So it not reading all the rows. So let me check once. Yeah. So it not reading full JSON records, it reading only few lines. And what we can do, one more thing is here. So actually what I started here is, what is the disadvantage of providing root path here? So whenever um, whenever whenever we have multi formats, so it tries to read all the formats. So this is the disadvantage of giving root path. But in case of previous case, so in this particular root path, since we have only 3 JSON files, it reading correctly. So it reading correctly. So 7 into 3, 21, it is reading. But whenever you provided root path, which has multiple formats of files, then this issue comes. Then what is the alternatives? This method. So now what I will do, so for mixed type, I will use this star.json. So what will happen in this particular root path? It tries to read only the JSON files. So here in this is the root path, and in this root path, I'm mentioning that star.json. So I'm mentioning like here need to read only JSON files. So if I try to read here, mixed uh, JSON. So now if I try to print, I will get this 21 rows, 7 into 3. Okay, so in this file has 11 records. So here 100 to 110. So total 11 is there. So 11 into 3, 33 records will get. So this is the advantage of providing at the end format. So in this mixed form folder, this how we can read only JSON files. But in case of, if I want to read only CSV files, so we have CSV files, right? Suppose I want to read only CSV files. What I'm doing, so I'm changing the code little bit. This is a JSON. And for reading CSV file, this up to here, this is root path. And after that, instead of start.json, I'm providing start.csv. So that means I want to read only CSV files. I want to read only these two CSV files. So Spark.read, whenever reading CSV file, the default options are option is header is true and option info schema equal to true. So if I run this one, only those two CSV files, it will read here. So here it won't go for any other format. And similar way, we'll try to read TXT files also. So we have few TXT files, right? 3 TXT files. So we'll try to read those files also. So here what I'm doing, instead of CSV, I'm mentioning start.txt. And this is same option header equal to true, info schema equal to true. Now, if I try to read this one, the two text files, it will read correctly. These two text files, it will read correctly. And the third text file, we have only lines, right? So this, the whole thing, it will try to read as single column. If I see here, so product ID, product name, category, so 1 to 9. So 1 to 9, it is related to first text file, and 10 to 18, this is related to second text file. And whatever we have third one, that whole thing we are getting under single column. So it coming under single column, and remaining all it filling as null. Because since we don't have delimiter here, since we have only text, so it all reading as single column. Okay, so, and that is the reason, even though this remaining columns, even though remaining rows, we have all integer values. Here we have, since we have this text string and the data type, it is mentioning as string. So otherwise, if you exclude this file from this folder, then it will try to read only these two files, two txt files, and your data type will become either integer or long data type. Okay, so these things when we'll use in real time is in real time. So there will be two pipelines. One is ingestion pipeline and one more is transformation pipeline. In ingestion pipeline, the data will come from source to our ADLS storage account. Okay, so in storage account, how this will happen? It will happen through ADF pipeline. In ADF pipeline, there will be one activity is created uh, to add the folders on daily basis. So that means if pipeline is running today, in our ADLS storage account, there will be folder will be created with today's date. If tomorrow running is, it will create with tomorrow's date. So once it move data from source to ADLS account with today's folder, uh, the folder will be created. And while starting transformation pipeline, it will pick the data from this particular, that means today's folder, it will pick the files and it will move to target. So while reading this today's folder, it depends on project. It may have single file or multiple files. So that maybe have depends on project or source, depends on source. It may CSV file or JSON file or Parquet or Avro, depends on our source. And at the same time, depends on project. The file may be single or multiple files on daily basis. So if assume that if your project uh, pushing the data on daily multiple files. So to read those multiple files, so we'll use this method. So always recommended method in real time is this one. So always mentioning this one, root path plus format start.json. So it will pick all the files of JSON files. If your input is CSV, then mention CSV. If your input is Parquet, you mention start.parquet. If your input is hour, then mention dot hour. Okay, so that is the main intention of doing this one. And as of now, what we discussed is infer schema equal to true. So that means Spark itself reading the data and detecting the data types. And initially we discussed what is going wrong while mentioning infer schema equal to true. So mainly few integer columns, even though it is like single digit, it reading as a long data type. So to avoid all these confusions, what is the best method in production or real time is explicitly defining the schema. So what is the advantage of doing this is one is faster than inference. That means faster than infer schema equal to true and prevents data type or schema inference issues. That means whatever I give an example now, instead of integer, it will detect as long data type. So those things we can avoid here. And how it is faster than infer schema equal to true. Whenever you mention infer schema equal to true, what will happen? The jobs runs twice. So one job is for scanning the entire data for first time, and for detecting data type, it will scan the data set again. So that means first it will go to first column. In this first column, it will scan all the data and it tries to detect the data type. And this example, in case if it is has only integer values, it will detect as integer type. But here we have mixed values. Integers also is there, string also is there. So whenever we have this mixed data, by default, it reads as string data type. So how it is detecting this string as, since we have integer and string, how it is detecting is by scanning this whole thing by using infer schema method. At the same time, here also we have all string values. It is detecting as string, and here also it will scan all the data, and it will detect as string. And here also it will scan all the data, and it will detect as integer. Okay, for doing this entire scan on each and every column, it will take some time. Okay, so that one job we can avoid by using defining this explicit schema. So here what I'm doing, I define the schema. How I'm defining the schema is, if you see JSON file here, whatever we saw JSON file, so it has two. So how it looking is JSON object, and same thing you can see here. The structure is from record number to zip code. If you see record number to zip code, so we have key value pairs, that is straightforward. Okay. So for record number, integer, for source, string, and this is long, this is long. So remaining all string. So we are defining like that, and we are following same order also. So how we have in JSON, so same column order we are following here. And if you see at the end, we have two keys, that is address and domain. Since these two are again JSON object, what I'm doing here is, this is the column name, key value, and for value, I created one more variable here. So here I define the schema. So in this, what are the columns we have? Total 4 columns we have: country name, username, location, pin code. So these I defined here. So while reading this one, so it will, this variable defined, right? It will pick this variable and it will try to read this schema. And at the same time, for domain, I define add schema domain. In add schema domain, I define this schema. So level, technology, experience, age. If I expand this one, technology, experience, level, age. Okay. So inside nested, individual nested JSONs, I define separate to more clarity. So if this whole thing, if I define here itself, it will be like messy type to understand difficult. So I written separately here. So now what will happen in earlier case, while detecting the data type by Spark, this record number, it detecting as long time. So record number, it detecting as long time. And if you see inside age, experience, these things also detecting as long time. So now since I defined explicit schema, and here for record number I mentioned as integer type, and at the same time if you see here age I mentioned as string type, and experience I mentioned as string type. So generally this should not be string type. Let me correct this one. Address domain, inside address age. So okay. So since age I given double quotes, right? So my JSON is prepared like that. Okay, experience is integer, age is 26. Okay, so here I defined as integer only. So what I will do, I will correct this one. So since I mentioned age and experience as string column, it reading as double quotes, and at the same time, you can see here also. So age and experience interpreting as string type. Now what I will do, I will change this one. So actually this supposed to be integer type. I will rerun this schema and I will try to rerun this file. And first thing, see here record number after defining schema, it reading as integer type. And at the same time, if I see here experience, I'm getting integer value, age, I'm getting integer value. Same thing we can observe here also. See here age and experience, I'm getting integer. Okay, so that is the advantage of defining the schema. And one more thing, since we mentioned schema in this order, same as JSON file order. So our the output columns also will be in same order. And this scheme also, you can see same order. How we have in JSON file, we will have in same order. And address domain, we have at the end in our JSON file. So similar, same way we'll get here also. See here, address and domain we have at the end, right? So we'll get same order. But in case of infer schema equal to true, what happened? It came default data. So address came at first, and this all these columns it got reordered. So that is one difference between infer schema equal to true and defining explicit schema. And one more thing is how to read nulls and empty string. Suppose if your JSON file has nulls and empty strings. So what we'll do first, I will show you the JSON file which has nulls and empty string. In this, I have 7 items. This is first item, that is a JSON object. And inside that, I have 12 items. And if you see here, description, I have empty string, and last update timestamp, I have null, and zip code type, I have empty string. And in address also, pin code, I have empty string, and domain experience, I have none. And if you expand these things, you will see like this, nulls and empty string. You can try to expand all the things and you can check. So here empty string, here empty string, and here null is there, and in address also I have empty string, and here also null. So now how to read this file which has nulls and empty string? So the method is same by using option multi-line equal to true. We see, so wherever we have nulls, we'll get nulls here, and wherever we have empty string, we'll get empty strings here. See here, wherever we have nulls, and wherever we have empty string, we'll get empty string. And same way here also, developer experience null. So here experience null and technology empty string. So level empty string, age null, and here also pin code empty string, pin code empty string. Okay. So remaining is same, schema will be same. So since here I'm not defined schema, means since I'm not added schema, this one, this option, that means it will consider as in first schema true. See here again it giving its own column order. Okay, and this one how to flatten the JSON. So as we discussed initial, so first I defined all individual columns, then I defined these two nested JSONs by using this one like address.pincode, domain.level like this. So we'll get finally all flattened records. Next, how to use permissive mode and explicit schema without underscore corrupt underscore record. So that means whenever we have corrupted record in our data frames, what will happen? It should create one column that is underscore corrupt underscore record. All the corrupted record should move to that particular column. So first we'll see the JSON file. What is corrupt record here? So this is the JSON file which has corrupted record. So we'll see what is the corrupt record here. See here comma is not provided. So here we are getting correct record where we are getting at the third JSON. This is first JSON and second JSON and third JSON. At the third JSON, we don't have comma. So while reading this one, so here what I did, schema I defined here, format I mentioned JSON, and option I mentioned multi-line true, and additionally added this option mode as permissive. That means even though if you have a corrupted record like this, I'm allowing to read the file. If you don't add this option, what will happen? It will throw you error. Okay, and this is the path. If I try to read, see first three files it will read, because first three files is the clean records. When coming to fourth record, we have bad record. Since we don't have comma, so it's stopping there and it throwing all nulls here. See here for even address, domain, everything it throwing null. Why? Because since we are defining explicit schema here, and here whatever I defined is what are the columns we have in our JSON file. I defined only those items I defined here. But Spark, what it does by default, whenever it finds corrupt record, by default it will add one additional column, that is underscore corrupt underscore record. Since that is not added in this schema, it not adding in this output. Now what we need to do here is, in this schema, this schema is the same whatever I explained earlier, no, that is same schema. Here one thing what I'm doing here is, since we have corrupted records, I'm adding one column here, that is underscore corrupt underscore record, and this should be always string type. So now same code, if I run here, now it will be added with one column, that is underscore correct underscore record. Since at fourth row we have corrupted record, so all the things it throwing here. See here. So the entire JSON it throwing here. And what we can do, one more thing is, I will try to remove this one, option mode permissive. Multi-line true, JSON, schema correct, multi-line true, mode permissive, multi-line true. So here what I'll do, multi-line as false. So multi-line as false. False. Here also I will mention as false. What difference we'll get here is it stopping reading the record where it finding corrupt record. So now what I'm doing, by changing this one, schema is not defined, I will rerun the schema, that is with underscore corrupt underscore record. So if I try to read this one, see here 3 and remaining all it reading as null. What I given schema is schema with corrupt. So schema with correct. What I should give is schema correct. One is schema without correct, and this is same only. It should read like this. That means wherever it finding bad record, it will throw nulls, and remaining it should continue. But uh, here what is there, schema correct, schema correct. Okay, same thing is defined. Here multi-line equal to true, schema is schema. Okay, mode permissive, multi-line true, mode permissive, and here also permissive. Only difference is multi-line false. That means multi-line is not required. Okay, so in single line complex JSON, it trying to read remaining rows, but here, if you see here, it is stopping here only, wherever it finding correct record, but here it continuing, but it giving the null values, and it dumping all the thing, but it should not happen like this. Schema with correct option, multi-line true, are same. Okay, I think okay, multi-line true I'm not added here. That only deleted, right? JSON mode permissive correct record with the correct schema with correct. This is fine. But why still it is not coming? Schema with correct. CROPT. Permissive read JSON multi-line nested JSON. Still coming nulls. Okay, I think there is some issue here, but actually how it should read is like similar way. Whenever you mention true, multi-line equal to true, you should stop there only where we have correct record. So whenever you mention multi-line is false, so since multi-line false is the default, it is up to you whether you can define or you can leave it. So, but actually it should read from this onwards, but somehow it is not reading. I think I'm missing some option here. More permissive. mm, Schema with correct. Okay. So, but the actual thing is it should read like this. So wherever it hitting bad record, it throw nulls and you should proceed with other records. Okay, so that is the thing. So that's all about this video on how to read multi-line nested JSONs using PySpark. If you really like this video, please like and subscribe. Thank you.